Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hanif bin Ghazali, and I would like to present about my proposal, which is students fatigue monitoring system due to online learning in COVID-19 situation by using EEG and heart rate monitoring. In this proposal, I would like to explain my idea on how to detect mental fatigue by using EEG and heart rate monitor. But for this proposal, only contain the preliminary result from the respondent form. The EEG and heart rate reading will be collected in further studies and will be used for the detection system together with this preliminary result. So the outlines of my project presentation is: first is introduction, second is literature review, third is methodology, fourth is preliminary result, and fifth is conclusion. Okay, for the introduction, in November 2019, coronavirus, which is COVID-19, was discovered. This is by the WHO, which is World Health Organization. So, during the MCO 3.0, Malaysia recorded the highest death rate due to COVID-19. From the Ministry of Higher Education, students must go through online learning without physically attend the university or college. So from the previous study, changes in typical face-to-face learning style which may result in negative health consequences such as fatigue. So for the first problem statement, students spend a lot of their time in front of the computer or tablet or laptop as a medium to use in their online learning. Then next is decreased outdoor social activities may have resulted in poorer academic quality and higher latentness. For the objectives of the project is: first is to design the questionnaire to evaluate the mental state of the participants. Second is to analyze mental state of the subject by alpha, beta, delta, theta, and gamma waveforms using EEG sensor, along with the monitoring heart rate in rest state and active state using heart rate sensor. Third is to develop a monitoring system to detect fatigue among students. For the scope of this project is, the questionnaire is done in online platform, which is by using Google Form. Using EEG sensor, which is emotive insight, and heart rate sensor from the Huawei SmartBand. I will analyze all the data using IBM SPSS 26. Lastly, all the data that have been gathered will use the SBM classification to either detect the respondents or the subject is fatigued or not. For the literature review, fatigue is a subjective psychological condition that people undergo as a result of the physical or mental exertion. This is by A. Arya and J. Bowen. There are two types of fatigue. The first one is physical fatigue and the second one is mental fatigue. Physical fatigue is effect on an individual's ability to maintain physical behavior, and the mental fatigue is effect on an individual's cognitive process. This is by YU. So, in this project, we will focus on mental fatigue. Fatigue has an impact on psychomotor performance, not only because of its physiological effects, but also because it influences decision-making ability. Mental fatigue can be attributed to alcohol, task stress, and lack of rest or sleep. For the reaction time, evaluating fatigue enables for the early detection of bad situations caused by a variety of factors. Reaction time is the initial step in developing a fatigue framework. Mental fatigue would lead to a worsening in response inhibition, resulting in increase in reaction time. When one is mentally exhausted, it is normally to predict performance deterioration such as reduced response time. Next is about EEG and brainwave. Neurons in the nervous system are interconnected with one another by creating neural sets, which are linked by a passage called a synapse, which enable activities. The electrodes detect electrical impulses in their brain and transmit signals to a device which records the effects. This is the example of the brainwaves. We have gamma, beta, alpha, theta, and delta. For gamma, the frequency is more than 35 Hz. Beta is 12 to 35 Hz. Alpha 8 to 12 Hz. Theta 4 to 8 Hz. And delta 0.5 to 4 Hz. ECG. Heartbeats in 1 minute is referred to as heart rate or pulse. Ray Laennec invented the stethoscope 200 years ago. by James Beckerman. William Enthoven invented the first electrocardiograph (ECG) by James Beckerman. Classification: a type of supervised learning which the input data is mapped to output data based on many examples, input-output pairings identified during a training phase. A classification that we use in this project which is support vector machine or SVM. 86% accuracy, demonstrating its suitability for mental state categorization by Guo et al. Okay, next is methodology. This is the block diagram that used in this project. The first stage is from the respondent form. We collect all the data and then we will call the participant to wear the EEG and heart rate monitor, and then the participant will do the simple test, and then all the data that we gathered we will use in the classification. In the respondent form, there are 4 parts, which is part A that will ask about age, sex, height and weight. For part B, the participant will be asked about their sleeping hours, smoking, alcohol intake, neural disease history, and medicine intake. For part C, the participant will be asked about the lack of sleep, lack of energy, lack of exercise, if they had stress from the study, poor study schedule, if they had insufficient rest break, and lastly, if they have a heavy workload. And for the last part, which is part D, they will be asked if they are interested to becoming the subject of this project. Next is flowchart. This is the flowchart that you use in this project. The first one is wearing EEG and ECG. After that, the participant will be asked to sit on a chair, and then they will be asked to focus on the breathing while their eyes closed for 5 minutes. In this state, the data from the EEG and ECG will be collected, and then they will be asked to start the test, which is the reaction time test. In this reaction time test, the readings will be collected, which is the reaction times. And then after 10 sets of the test, the EEG and ECG data also again will be collected. So this is the preliminary result from the respondent forms. The first one is the gender. We can see that we have the balanced amounts of frequency from male and female. We have 50% from male and also 50% respondents from the female. Okay, for the highest frequency for the age is 37.5%, which is for the 23 years old, and then 20.8% from the 26 years old, and then the 12.5%, which is from the 25 years old respondent, and then 8.3% from the 24 years old respondent, and finally all of the respondents have the same value, which is 4.2%, which is for the 21, 22, 27, 29 and 38 years old. Okay, next is for the sleeping hours result. You can see that majority of the respondents have choose 5 to 9 hours of their sleeping hours per day, which is 7.5%. Other 12.5% they have to 8 to 10 hours sleep a day. Okay, next is for the smoking result. Majority of the respondents, which is 83.3%, have stated that they have not smoked, while we have 12.5% that smoke 1 to 3 times a day, and we have only one respondent that chose 7 to 10 times a day that they have smoked. Okay, next is the ANOVA result that have been analyzed using IBM SPSS 26. This ANOVA analysis will be used to calculate the significant difference between the BMI from the height and weight of the respondent between the characteristic of the fatigue, which is lack of sleep, lack of energy, lack of exercise, work stress, poor study schedule, insufficient rest break, and heavy workout. We can see that the significance from each of the characteristics is higher than 0.05, while we have set the 0.05 become the significant difference. Beside the ANOVA analysis, we have this graph that will be analyzed between the BMI and the mean of lack of sleep. We can see that overweight and obesity respondents will have higher mean of lack of sleep, while normal and underweight people they have lower mean of lack of sleep. Next, the graph shows that the BMI versus the mean of lack of energy. We can see that obesity and underweight respondent have the highest mean of the lack of energy, while normal and overweight person have lowest mean lack of energy compared to obesity and underweight respondent. Next is BMI versus mean of lack of exercise. We can see that obesity have the highest mean of lack of exercise compared to normal respondent. We have the lowest mean of lack of exercise. Next is BMI versus mean of work stress. We can see that obesity and underweight respondent have the highest mean of work of stress, but while normal and overweight respondent have the lowest mean work of stress. After that, BMI versus the mean of work or study schedule. We can see in this graph shows that overweight and obesity respondent that stated that they have the highest mean of full study schedule, while the underweight and normal respondent have the lowest mean of full or study schedule. Next is the BMI versus mean of insufficient rest break. We can see on this chart, underweight and obesity respondent have choose that highest mean of the insufficient rest break, while normal and overweight have the lowest mean of the insufficient rest break compared to obesity and underweight. Next is BMI versus mean of heavy workout. We can see that obesity respondent have the highest mean of heavy workout, while the normal respondent have the lowest mean of heavy workout. Next is the result for the duration time. We can see that from the respondent form, we have 24 numbers of the respondent, while in the reaction time, only 10% that willing to take the reaction time test. We can see from here statistic, we have the 50% from male and 50% also from female, which is 5 and 5%. Next is the reaction time for the participant 1. The dotted line is the trend line, which indicates that the decreasing pattern for the participant 1 that have the lowest amount of reaction time compared to their first test. Next is for the participant 6. We can see here the dotted line, which is a trend line, shows the uprising trend, which is the after the 10 sets of the test, they take the highest amount of reaction time compared to their first test. Other participants will be shown in the result in the appendix of the reports. Next, we have the result for the gender versus the mean of the total reaction time. From the chart given, male respondent have the highest mean of the total reaction time, while the female has the lowest mean of the total reaction time. Here we can conclude that female has take the fastest reaction time compared to male. Okay, next for the conclusion, there is no significant difference between the BMI group of the respondents and the characteristic of fatigue, which is P is higher than 0.005. Next is only 41.67% of respondents are willing to take the reaction time test. For the future work, EEG and ECG readings will be recorded also. And the second is all respondents must take the test. And finally, the classification will be done using the SVM classification. That's all from me. Thank you.